So if she could age, say, well, let's see, if she ages 0.8, so I went 22.4 plus some number is going to be equal to 36 plus however far he ages. So this would be, say, time that Sue ages the second time. Call it TS2. This is the time that Lou ages the second time plus some integer.
So then now for Lou, that would be the proper time when he gets.
If Lou gets in the rocket ship now and takes off, then yeah, Lou would be proper time. So we'll have a second gamma.
And so time of Lou the second time times this second gamma is equal to time of Sue.
Second time for Sue. And then n is some integer, whatever the difference in their ages is, if they're having the same birthday. And then it's just, you have multiple equations. We can throw in extra restrictions. Lou's going to the same planet. Lou goes to a planet 2 times the distance. Lou goes explore some other place. It's gone for 5 years. Loads of variations. So do you want me to explore one of those variations, or do you? I think Precious, you're the one who started this.
Yeah. What do you guys?
I'm okay with it.
Okay with this, or okay to
Yeah, explore more.
explore more? Okay.
I feel like in the future that might be a thing. People trying to have the same birthdays.
Probably have 0.988, so that's people.
Yeah, definitely possible.
Thinking how sad it would be that someone gets excited. You'll see them on whatever the YouTube variation is at that point. I have the same birthday as
Oh no.
Kylie Jenner's grandchild.
I have a question pulled up. If,
Okay.
or do you wanna like keep the numbers?
Oh, we'll keep these numbers.
Okay. It is Lou's turn to travel near the speed of light to the same distant anomaly and Sue to stay on the home planet. What is the minimum speed which Lou can travel so they share the same biological birthday again?
Okay. So they're not saying they're the same age, they just, like March 5th or whatever the date is. And I'm not playing the trick of, a leap year gets thrown in there to mess everything up. All right, so we have those numbers right there. And so we basically have that equation set up there. So I know that 22.4 times however much Sue ages on Lou's journey is equal to 36 plus however much Lou ages. And then there's an integer difference. So presumably, it depends on, do you want n to be a positive or negative number, the integer difference? Because Lou is starting out older, so it makes sense that Sue is going to stay younger. So whatever this is, plus some integer, it really doesn't matter, just so long as you know whether it's going to be positive or negative. I know that time of 2s is equal to gamma 2 time of Lou 2. I guess that should be S2, which I believe is written over there.
Would that be a plus or you have to multiply?
This?
Time pursue.
Oh, that should be a plus there. Thank you. I put it correctly on this side. Something about over there that messes me up. And we have one other restriction here because this is going to basically give us a speed here, but he's traveling to the same distant anomaly. So I know that the distance traveled, well, presumably I've already calculated it, Cause I know gamma from the first grip, and I know, oh, yeah. I know, there we go, also B. I know the distance. So that's not changing if it's the same distant anomaly. And so LP, for which we would have a number, is equal to gamma 2 times L, which would be gamma 2 times however fast blue is going times the time blue is gone. That's how far away it is from blue's point of view. I guess VL2, sticking with that convention. And so now it's it's a math problem.
VT is for Lou, and how P would be for Sue. VL2.
VL2, this is how fast,
That would be for Lou.
yeah, well, technically it's how fast Lou sees the planet coming towards him.
And then how P would be how, Sue, sees the distance between them.
Oh, LP, you said?
LP is-
That would be the distance from Earth to the distant planet or anomaly. That would be now how far Sue says it is away. Which should be the exact same thing as what Lou had figured out, how far Sue was away. And so I got some fun little equations here. Do recognize that this V right here, the how fast Lou is going relative, or how fast Lou says the planet is coming towards him, is also the same speed that Sue says Lou is going. Again, similar to the muon things, they agree on the, or take this case right here, Sue and Lou both agree upon the speed, they just disagree about what's going that speed. Lou, the first time around, Lou said Sue is going that speed. Sue is claiming that Lou and the distant planet were going that speed. So this is 1 over the square root of 1 minus V squared, this is VL2 squared over C squared, times VL2 times TL. And so at this point, I can plug this in for T2S. I can solve then for, so now I have TL2 and TL2, I can now solve for TL2 here. This is equal to LP. So TL2 is equal to that LP square root of 1 minus V. At this point, I have only one V involved, I'm just gonna drop the subscripts there. This is VL2 squared over C squared divided by V. And I take that and plug that in for here and here. The last thing, I now have an equation with actually two unknowns. The first unknown is V, that's unknown. The second unknown is N. Well, N's an integer. So I can start out with N is equal to 1, and then N is equal to 2, N equals 3, until I get something that works. This one here, how you want to solve it. So we have N plus 22.4 plus let's see, so we have gamma 2 times LP square root of 1 minus V squared over C squared over V. V equals 36 plus LP square root of 1 minus V squared over C squared over V. We do have one nice little simplification here. That cancels out with that. So, n plus, we go ahead and combine those, that was 13 point, so n over LP over V equals 13.6 plus LP square root of 1 minus V squared over C squared. Solving for V, so it looks like we need to multiply by V to get rid of my fractions here, so we can ultimately isolate my radical. NV plus LP equals 13.6 plus LP square root of all that stuff. So NV minus 13.6 plus LP equals LP times that thing. NV over LP minus 13.6 over LP plus 1 is equal to that square root there. So now ultimately I'm going to end up with a quadratic. Feel like we took a wrong turn somewhere, but alright, so Sue's age when she returns, and then plus how much she ages. Is how old Lou was when she returned, plus how old he will age, and then the difference between them is some integer. Alright, so times.
I multiplied V out, right?
Yeah, in theory, when I went from here to here, I multiplied by V.
So it would be 13.6 V.
It would be, thank you. So we then, well, you know, it's a quadratic. How are you going to solve a quadratic? So we have n minus 13.6 over LP times V plus 1. Gotta be careful about rounding here, because LP is gonna be a huge number and n minus 13.6 is not. So you do have to be careful about the rounding. Because V is also gonna be a huge number. So just to simplify it, let's let that be A. So now, A squared V squared plus 2AV plus 1 equals 1 minus 1 over C squared to V squared. Ones can immediately cancel out, so I'm left with A squared plus 1 over C squared V squared plus 2AV equals 0. And at this point, I'm thinking, well, we probably made a mistake somewhere, because one of the solutions would be v equals 0, and that does not work. So now it's a question of how much time do you want to spend trying to figure out where the mistake is. But in theory, assuming there is no mistake here, v would be yeah. Yeah, and another issue here is that, because it does tell us something here though. I was thinking there's about to be another mistake because this will be negative, but not necessarily. I know that if a is a positive number, we get a negative v, which doesn't make sense. But a has to be but v has to be positive, therefore a has to be a negative number, which tells you that n has to be less than 13.6. So we do have a limit on n. So my two extremes for n, since we set it up so that n would be a positive number, is that n is equal to 1 or n is equal to 13. One of them is going to give us our answer because we're looking for a minimum. Potentially, I would start at one end or the other, probably 13. That's saying that if n is 13, that means that we still have a big difference between their ages, which means that Sue did not age a heck of a lot. So I started with n is equal to 13, find a, solve for v. Does it make sense? No. Move on to 12. Does it make sense? And keep going. Anyway, that's the approach. Or if you know how to use your calculator to solve such problems, then there are a couple of places that you basically have, after we plugged in this right here, make up a value for n, and then look, you have two functions as a function of v, see where they cross. Personally, when I solved it, I went into Excel and I just did a brute force. Because I kept trying to solve it analytically and kept making careless error after careless error, and then I thought, let's just set up a spreadsheet.
Can we do that during class?
Yeah, only if you can do it on your calculator. I'm trying to think if we open that up so that not only one person could use it at a time, and they might be on it for a half hour, which means everyone else would not be able to get to it really. Other questions? In general. It's a fun little problem, isn't it? I'm sure what you're thinking right now, let's see if I can read your mind, you're just thinking about, does rejoicing get any better than this? And I'm thinking, there were a couple other times, but this is pretty darn good.
I think it's deceivingly simple looking.
Say it?
It's deceivingly simple looking. Like, it looks simple because of the formulas. But then that happens.
What one professor, and I'm sure I've mentioned it before, the conservation of complexity. The fewer letters in the formula, the more they get stuffed into the letter. Because everything that we've done from the textbook There is actually one equation, there is an equation which describes it all. Which is basically, it's one letter with 3 subscripts equals 0.
It's in the textbook.
I said all the stuff that we're, in the text that did for this course, that's in the textbook, not the quantum stuff, everything other than the quantum stuff can be all summarized into a one little equation. But there's so much packed into that one equation that generally the technique is not to start with that and then expand on it, it's to do it step by step. And ultimately, if you take physics long enough, they'll eventually they'll get into what's called a 4-vector, and they'll come up with that equation and basically sum up everything you did in this course in just a couple of little letters.
Dr. Fox, what chapters are in the test again?
Every chapter.
Check.
I think, 31, 32, 33, 34, 39, and 30.
So yeah, it starts with 30 through 33 definitely, part of 34, 39, and then quantum is for fun.
Wait, quantum is in the test?
No, it's for fun.
Okay.
Oh, yeah, not, there is currently not a quantum question on the test, if I recall correctly.
Optics is not there, right?
Right, optics is not there.
Have you ever done optics?
I have, there was, at some point early on, I was saying, all right, if we have time, do you wanna do optics or quantum? And, I had a student, sat over there, said, oh, we really wanna do optics. And other people were just, sure, whatever, he really wants to do optics. And so we had basically one day to do optics, and he was absent that day. So he took the course again, he didn't like his grade, so he took the course a second time, and so again, he put in the push for, he really wanted to do optics, and he was there that time. I think we had 2 days that day, that year.
Back when the semester was longer.
Say again?
Is that back when the semester was longer?
Yes, the 16-week.
Yeah, it feels like we have no time to really study everything in depth.